Good evening, y'all. Welcome back to another Saturday night. I know, and I guess not another because we missed last Sunday night. But we're but we're back to do more things. And if Cookie has their way, we'll set some things on fire. I think Cookie, it's unlikely to happen tonight, but I guess never say never. Considering we'll be getting the 3D printer going in just a little bit here. Yeah, it's good to be back. Sorry, so the pre-roll, the camera shot here is just me having a little bit of fun. This has been the project I've been working on a fair amount of my extracurricular time this week. This is a project for a client that I'm currently working on. That will be, I'm going to tell you the side story of it in a little bit, I think, once the print is going, because it's driven by Arduino. It's driven by Arduino and it's driven by DMX. So not in its current firmware, but if I come over to, well, that's the logic analyzer. If I come over to Visual Studio Code here, and I open up the correct firmware and I load it back up, we will see, here, let me just load up, let me load up the one that actually speaks DMX. And we can just show that off because I'm rather proud of it. But like I say, we'll try and put off the fun of that until we have a moment to actually properly tell a story. Let's see here. So I'm going to upload this straight from VS Code. Make sure that's disabled. Preparing boards. We're verifying. We're uploading, and hopefully, if all has gone well, yes. All right, so let's see here. So let's take ourselves back over to this guy, and we'll see. So if I'm in, I should turn on my DMX controller. So this thing has a couple of different modes. Here, I'll see if I can do this in such a way that we can actually see the DMX controller at the same time. So it's got 3 channels of control. We've got sort of a primary control mode channel. So channel 1, if it's below 50%, we're in this pre-running effects mode here, where we just count up and then reset. If we're above 50% on the first channel, we go into what I call raw mode, where the second channel is just literally just a giant DMX display of what level the DMX is at. And you see it only goes to 245. That's just because this is like a $30 DJ DMX controller and the pot slipped. So I can't actually push this slider all the way to the top, but it really genuinely does just show the level of this channel of DMX. And then the third channel is kind of an effects channel. If it's below 0, things are on. If it's between 1/2 and 3/4, it's flashing. And then above that, it's just a blanking display. As specified by the client. And so this has been a fun thing to work on for the past few weeks. And like I say, I want to show you a little bit about what's going on in the Arduino code in a little bit, because I think it might be useful for some of y'all in pursuing Arduino-y controlled DMX things. It involves sort of taking the DMX library apart a little bit and doing some other things with it. But the focus of what we're going to do tonight is not specifically that. We're going to work some more on the Tiny DMX Winch project and pick it right back up. So, as y'all will recall from a couple of weeks ago, this is sort of where we left things off with this winch and ratchet mechanism, which had a few issues, right? And we left a few places that we were going to improve this in terms of the relation of the spring to these little hooks, and how we were sort of securing this all in. But the basic functionality is there, so that if we were to drive this threaded side, if we were to drive the what did we call this? The friction handle that goes on this side with a stepper motor, we could be applying a ratcheting, a winching motion to the output shaft here. And so in order to really test that, we're going to need a few more 3D printed parts so that we can actually hang some things off of this. So I think that's what we'll start with, is designing a little hanger bracket for what will be what we'll call our lifting batten. Maybe not batten. Batten is probably the thing that's hanging off of the lifting lines. Our drive shaft. Drive shaft is plausible, right? And that's just going to be, I chopped down a little stick of this 3/16 steel rod here. Now, exactly how this couples to our 3D printed mechanism, I'm also not sure yet. But that'll be a thing we'll have to solve as well. But I think just to rev up the engines, because it's been a little bit of a while since I've actually touched this project, let's do the simplest part first, which will be just a mid-shaft support. So it's going to have something that's going to have a bearing in it, much like this one. In fact, it'll probably steal Actually, I don't know if I have this saved anymore. I think this turned into this, because this was just a test fit part. And then we'll put a couple of adapters on it, like we have for the lights in the micro stage, right? Which, as you'll recall, all have... Pop one off here, and we'll pull another one out of storage as reference, right? But these all have our little snap-in connectors here. And so we're going to reuse those. And I'm hoping to do this in a way such that I can parameterize the distance from the truss to the center of the bearing in a way that if I get it wrong, or if we want to adjust the separation of the winch and the truss at any point, changing what this part will be, this shaft support, will be a really simple job. It'll be changing one parameter, and everything else should recalculate. That's my hope in any case. Cookie says planned tip for attaching the shaft to the ratchet was, or I guess whatever your drive mechanism is there, Cookie, is notch the shaft and Loctite a grub screw. Yeah, not a bad idea, right? Like, you put a notch or make it like a D-shaped shaft, right, where you shear off, like you shave one side down to be flat, and you can put a locking screw in there. Yeah, not a bad idea at all. That might honestly be the way we go. Maybe it's shave it down, and then we'll make the, we'll put the output side of the shaft here. We'll probably make that slightly D-shaped as well, but that doesn't seem like a super reliable way to hold on to it. So yeah, maybe a grub screw is the way to go, just sort of out hanging in space here. That seems pretty nice. Yeah, well, let's get to it. I think Fusion 360 is already loaded. There's going to come a point tonight where we have to stop fusioning if we're still going. Because tonight Fusion 360 is undergoing scheduled maintenance, I think from 9 p.m. to 10 p.m. Central Time, which is my time zone. So we'll see how that goes. Oh, here, I can get rid of that. And let me load up. Let me see if I did save just that one little test block for the winch. I don't think I did. I think that was like the very first couple of steps of the other design. Yeah, it looks like I didn't. But that's okay. We're going to start a new design, and we're going to steal some dimensions from this other design because they seem to be working out quite well. Namely, I guess, the diameter of the hole that those 608 bearings are going in, which I've settled on as 22.2 millimeters. Okay, so let's start a new file. We will call this the mount. Yeah, hi Chris. Yes, it is indeed not. It is a Saturday night. How wild. We'll name this mid shaft support. We'll save our file. Yes, a little story about that as we start roughing in our mount here. The reason that I missed last Sunday, and the reason actually that we're doing this on Saturday night tonight, is. Last Sunday, so as I mentioned, I think the week before we saw each other last time we saw each other, I am fully vaccinated now, which is incredibly exciting. 34.2. So last Sunday we had my wife and I had a relative come into town, and in a very small gathering, we went and saw them in person, and our plans ran a little late. And just the idea of having the ability to have plans that go late into the evening, that alone blew my mind. It was lovely to see this person. It was great. But like, it was like, oh, I have to like consider that there might be more than one thing going on in my life. Wild. So sorry to just bail with no warning. It was a lovely time. And similarly, tomorrow for Mother's Day, we're going to go back out and see this relative who's in town. So here we are streaming on Saturday night. What a good time. But yes, I apologize for messing with everybody's heads so severely. I will, no, probably, honestly, I'll continue to do that, because that's the streamer's prerogative, I think. All right, so we're just going to rough in a really simple shape here. Use the mirror tool to bring that across. I realize, I don't discuss too much, like, the specifics of how I'm working through, individual like design steps. Like now I'm going to mirror, and now I'm going to extrude, because I sort of assume, I guess, that people more or less understand the basic steps, but maybe that's not a fair assumption. What am I dimensioning here? Let's call this this is actually what's going to want to be parameterized, I think. we'll have to figure out how we do that. We'll just make it 10 for now. Oh, we'll make it 10 plus this divided by 2 plus this offset, and that should give us 10 millimeters there. So yeah, so if I'm happy to like go deeper into like the fusion steps, but I also don't, if that's not necessary, if people are like, yeah, get through the fusion, we want to talk more about Fire or DMX or, whatever all the other things are, I'm happy to do that as well. I'm no fusion expert. I use it quite a bit as a hobby and for work, but like I'm not a professional drafts person by any stretch, so I'm sure that there are things that I'm doing in a non-standard or less than optimal way. So I don't take this me being like, oh, I'll show off my fusion. No, that's not really a thing. Chris, what program are you using? This is Autodesk's Fusion 360. It's a free for hobbyists program. It's really great. All right, so we might actually have to do some thinking here. And what I think I'm going to need is a couple of. I'm just gonna pop this moving light back off of the stage here. It's a couple of our little clippies. Ooh, Chris banging out a broom camera adapter? A broom camera adapter? A boom camera adapter? Chris, what's a broom camera adapter? So the idea here, and we'll kind of do this in profile view, if you will, right? So as you the camera would be looking at this from the side. What we need is a support that holds this bearing collinear to this shaft. Now, where exactly this shaft sits in space is also slightly indeterminate, right? Because this does not have mounts on it yet. And the stepper motors, right? Also, we haven't designed that mount yet, so those don't have a definitive height. There's nothing that's setting the distance of this bearing from the truss at the moment, except that, I guess let me pull a motor out and check. I'm pretty sure even if I were to flush the stepper motor up, let me get it out, and then we'll find out. And I'll find out if I'm lying before I tell the lie. So there's our stepper motor, which is sort of a flatter version of a NEMA 17. I'm pretty sure that I sized this winch so that, yeah, so you can kind of see there, even if I end up designing the stepper motor mount such that the stepper motor is flush to the truss, it's still, I don't need to necessarily move this down any to accommodate. So this is currently setting the winch mechanism is currently setting our minimum distance from bottom of truss to center of axle. So I don't need to worry about the stepper motor for tonight. I can sort of start with this. And what I want is to create a structure that uses our snap clips and basically snaps into a couple of holes, something like that, on our mount. And then the height of them is parameterized. So when I say, okay, center of axle to center line of truss member I'm going to set that at 18 millimeters. I can put that in as a user parameter, and then this model will adjust to accommodate. That's the dream. We'll see if I haven't really thought that through. We'll figure it out. Chris says, need to mount a gimbal to the end of a 20-foot paint pole. Bottom of the gimbal has camera threading. Oh. So really a broom camera adapter. Like for it. Why are you putting a camera on a paint pole? Chris, you are another person who always has interesting challenges. I'm sure this year especially. So let's see here. So what I should probably do before let's go in and define our parameter that we're going to want to use for all of this as a user parameter, and we'll call this bearing center to truss truss member center line. God, that's awfully verbose, but it's going to remind us when I pick this up, whenever this project falls off the board and then comes back, as these things always do, at least I'll remember what that dimension was supposed to be. So what I really want is for this dimension, this bearing here, to be that truss, do you remember, center line minus some amount of clearance, I imagine. And I may have to come back and rework this, but let's say, now obviously we're going to have a little bit more than that, so probably that's going to start to inform what this dimension actually is. Let's say it's 25 millimeters, an inch or so. Ah, Chris is getting a drone shot without a drone. Yes, very cool. Yes, yeah, stick it up on a paint pole is the poor person's drone, as it were. That's great. So now let's bring in our snap clips. So let me go into my back into my Demilight folder. We haven't seen the Demilight 3D model in a while. Let's see here. That is in the Moving Light PCB folder in my Fusion files, because it was originally a project to build a PCB for moving lights. Well, you know what? I'll bet it's still in my my editable documents folder. I bet. Wouldn't that be handy? No, it's not. Wow, it's been so long. I took it out of my my editable documents folder. Let's see. I just got to figure out which version is the most current. Moving Light 9-4 models from the end of January. Pin experiments. Ah, here we go. Pin squeeze clamp. Ah, yes. So this is not the final orientation of the hook itself, because you'll see that ultimately we turned it 90 degrees to make it more printable, and then I lost this Fusion file somewhere in the transition between computers, but this is the right shape of the pin, which is really what we care about. And for some of the other designs, I've been really particular, like for the Demilight base, I've been really particular about having these sort of cruciform holes, because I really wanted these pins to be able to snap in either of two orientations. But I think for this project, it's going to be sufficient to say these are always going to be hanging under a piece of truss. Like there's not much of a situation where they would want to hang this way. So I think we're just going to do a simple single axis hole, if you will, for these, which is also going to simplify things quite a bit. So that's pin squeeze clamp 3. So let's bring a couple of those into our project as other root objects. Pin squeeze clamp, yes, that's fine. There we go. And you know what we're going to want to do is, let's see. Before we do that, let's try an experiment. What I think I would like is basically, so I want the position of these hooks, of course, to be in the correct vertical elevation relative to the center of this bearing, right? Which is, because of the way that these are tangented, this is actually going to be, I'm going to do a plane at angle through this point. And then I can do an offset plane, and that's going to be our user parameter distance. So this currently is where the center line of the cord of the truss is, right? That plane is this plane cutting right through the center of that circular member there, at least in theory. And I can already tell this is going to be too small. But let's just kick it up a little bit, and hopefully everything should just recompute. Yeah, so we still have that, like, 6 millimeters of clearance, which I probably want to dimension that off of a different parameter, but that's all right. So what I'm thinking is that we'll create, we may have to do some offsetting here. So let's go look back and look at our pin to figure out exactly what I'm wondering is, if I create a sketch and then I use a move to point command, for example, to move an imported object so it lines up with that sketch. If I relocate that sketch, does the object move with it? I don't think that made a whole lot of sense. Let me try it. So what here we'll make a rectangle, and we'll make sure we have a point there. Okay, so now what I'm wondering, this obviously is not the final design, but if I take this pin squeeze clamp, yes, I would like to import it, please, thank you. And I say, okay, that is going to be I'm going to bring that into location. I'm going to move its tip to be at this point on the rectangle. And I say, okay. And something is broken in this model already. What is broken already? I don't know. That's fine. The model's, one of the chamfers is broken. That's fine. This is not the real pin anyway. So now that we're here, what I'm wondering is if I go back into my user parameters and I change this to 40 millimeters, and I hit OK. Yeah, this is what I was afraid of. So this sketch moved up, right, because our offset plane here was based on the distance from this point upward. Like, that's now 40 millimeters, but of course this part didn't move with it, which is really what I would like to have happen. So putting these hooks directly into place and then modeling around them parametrically is clearly not going to be a workable solution. So what else could we do here? We could, once we formed the hole into a shape, into an object, the thing is, like, if capture position is not something that changes based on user parameters, I don't know. I'm not sure if this is. I might have to actually determine these dimensions and not do this parametrically, which would be a real shame. I guess before I get too much further, let me think about this. So this is our real pin. So we want our holes, as it were, in our mount to be crosswise along our mount. In other words, we want the pin to be oriented like that, not like that. So this pin on screen, though it looks like the hook is wrong, the hole is right. Will it work into an extruded piece instead of a sketch? Oh, that's an interesting thought, Chris. Let's find out here. I'll just undo all of this. We'll get rid of that sketch. And we'll say, we'll bring in our squeeze clamp. Let's see, we'll move this out here and we'll do a point-to-point move. So like to, for example, this corner of the object there. And then if I do a change parameters and I make that 40 millimeters again, yeah, I don't think, yeah, so that has not moved. Has not moved with, unfortunately. Make it a joint. Yeah, that's a thought. Joint, let's make this a simple joint between 1 and 2. And I probably should do an as-built joint. Yeah, So let's see, which one of these is my as-built joint? So components, that one, and this one, rigid joint. So those are joined. So now if I change my parameters to 40 millimeters, no, they're rigidly connected, but they're not changing with each other, which is unfortunate. Trying to think of some way that we, like, if we had, like, if these two things were a singular, like, what is the parametric equivalent of a move command? Like, I'm trying to think through it. Is there a way that we could, like, basically surround this? Chris says it should move if it's a joint. Could make them a rigid group. Yeah, Chris, check me here. I might be doing something wrong. Let's see. Components, so I want that pin and this pin. A joint already exists. Oh, I don't want it to continue. No, let's get rid of that joint. Make them a rigid group. Does that help us at all? What I think is happening here, Chris, is the things, because they're rigid, they aren't moving relative to each other, but what's happening is I'm just changing the size of one of them, and like one of the size of one of its faces. And so like these two things are still like locked together in a sense, but now this one is just bigger and inside of it, I suppose. Like, what other operations could we use? Like it's like snap to face or extrude to. You know what we could do? Extrude to object feels like it has some possibilities, right? Like position this thing's mount where it needs to be, and then extrude this some form up to medium, and it would kind of limit our basic size. Let's get a better sense of what that actual size of this is going to be. Let me grab my calipers. So like, let's say this winch had some small amount of offset from the truss. You know, picking this sort of just by eye. I just want a sense of scale here. So that's like 10 millimeters off the truss. Let's say we're 6 millimeters off the truss ish. Then I don't want to depth this. Just really, really roughly speaking, we're talking about, yeah, like 30-ish millimeters. So that'll be a decent place to start. So let's get ourselves a better sense of this problem. So let us just move this whole component around. Let's find a better place to grab it. How about like there? I'm just going to really roughly align. We'll do this with like a sketch and a point-to-point move in a sec. I just want to get like a visual of what this is going to potentially look like. So this is going to be basically like that. Now this hook will be going 90 degrees to where it currently is, but this is the orientation that the pin wants to be in, because again, this pin doesn't exactly match the physical the pins that we're using. So, wow. Maybe we're coming at this wrong. Maybe we came at this backward. Maybe we put these two pins in place. We create the object that is like the plastic that surrounds this pin. And then we do like a sketch that dimensions off of that and uses that as our user parameter. I think that's the way to go. We'll start over. We'll delete some things. We'll delete some other things. We just have our pin. And we'll start from here. Okay, so let us duplicate this. We need 2 of them on 44 millimeter centers. Thank you, Cookie. .44 millimeters. Create copy. There we go. Okay, so that's the position of our pins there. And actually, you know what we should do? We'll just build the mounting piece once, the surround that sort of wraps around these pins and holds them, and then we'll just duplicate that on 44 inch centers. We're not doing the same thing twice. So let's construct a plane at angle again, right through this middle portion here at a 90-degree angle. And we'll create a sketch on that plane. Let us intersect our body with our plane so he has something to work with. And let's just hide this for now. I realized I didn't do this in a component, which I really would like to do. Let's undo, we'll create a component. We'll call this the hook holder, and we'll redo our steps. So plane at angle through the midline of our pin at 90 degrees. Create sketch on that plane and intersect our pin. There we go, and hide our pin. Okay, so now let's create our holder here. I think we're just gonna make a nice easy circular holder. We'll center it up. I guess you don't even need this perpendicular. We'll just use the center of this line because everything's nice and symmetric. We'll drag our circle out here, and we'll say that this distance is, we'll say that. So this is something I find myself doing a lot, and maybe there's a faster way to do, but when I want to dimension laterally, I guess I could do just a horizontal line from this point and dimension that. For some reason, this feels wrong to me, but I can't really justify why. So we'll do that, and we probably are going to need a couple of lines just here to do a cut in a moment that I can see coming. But yes, so let us finish our sketch. We will construct, I think I'm going to need, let's see. Probably can't do a tangent plane through this point at the end here. I want is like a plane, well, you know, honestly, we can just eyeball this. So we'll just extrude, let's extrude the whole ding-dang circle down, the whole cylinder here. And we're not going to parameterize it around that, around this point, because I'm a bad person. Let's make this 16 millimeters. Make this 15 millimeters. Okay, so that's our cylinder. We will do a combine cut, and I will keep these tools for now. There we go. Let's take that away, and now I think, if I turn my sketch back on, I should be able to extrude this center portion down so it like just cuts, well, honestly, probably just, oops, cuts down through there, and, but it's got to go all the way to the bottom there. Let us do an extrude to object. Let's see if I can just go to the bottom of this thing. Cut. Oops, that's not quite what I meant to do. I mean, that would in theory work, right? Because that hole at the bottom is not a critical part of the profile. But it's not quite what I meant to do. As long as it goes below the bottom of our, let's see, how deep do we want to cut this here? 13. We'll be a little lazy about this. Yeah, so our tip, the thing is that like the tip is circular there so that it could rotate in the original design that we borrowed this pin from. But this is specifically going to be a non-rotating pin. So I'm not super worried about it. That should be all right, right? Stick right down in there. Okay, so that's going to be our pin encasement mechanism. And in fact, let's tidy this up a little bit. We don't need all this extra plastic out here. Let us, we'll just shave a little bit off. Put a horizontal line there. We'll mirror it across center. I really like using the mirror command. I'm sure I'm not alone in that. But I find it a really, like, I'm so often making symmetric things, and so it's like, well, I'll just do it once and then I'll mirror it. I'll make that like a 3 millimeter. Sure. And then in our original extrude, we just won't extrude those two portions. And so now we have a slightly tidier looking block, as it were. In fact, we should probably square up one of these sides as well, because that's going to sort of flow into our mount. Square that up, and then we'll just not extrude that side. And there's our pin holder. Okay. So now what we need is I wanted this to be 44 millimeters center to center, and the easiest way I can think of to parameterize that is, let's go back and do our sketch. We'll give ourselves a center line here to work off of, and we'll do I don't think I can offset plane directly from this line, can I? No. So we'll do a plane at angle on that line. Do I need this? No, I can just do this in the, oh, but you know what? I need a plane to mirror around, ideally. I guess I could just do a move copy. Maybe that's easier. So let's do a move copy of this component. And we'll swing it around. Oops. Gotta do a move copy of the whole component. Gotta select create copy before we start moving it. Oh, selected cannot be copied. What was that about? Components, this one. I say create copy, and it says the selection cannot, oh, it's gone. Cannot be copied because it contains the active component. Oh, I think it's saying I can't put this copy operation inside the timeline of that component itself. I have to do it exterior to that in the main timeline. I guess that's reasonable. Create copy. Yeah, I guess that would be kind of a recursive timeline there if you let you copy components inside of the component itself. All right, so we'll capture that, and now here is our supports, and here is how we're going to solve our parameterization problem. So I'm going to put our bearing, make a new sketch on the mid plane between these two. We'll create a new sketch on that plane, and we're going to project in this line, which should fall basically on the center line of our truss members, because that's our vertical tangent there. It's going to connect right in. And because of how these squeeze onto those members, that tends to be, I think, pretty true. Is like the truss ends up right there. So that's what we can dimension off of when we, come down here and say, here is my, I guess let's get our shapes in here. Let's get our good shapes. And now we'll find the center point between the two of them. Bring it down here. These can all be construction lines. And now if I say, okay, here's my circle of diameter 22.2 millimeters that we remember so fondly, and the distance from center there to center to this line, which is the center line of our truss, is going to be our user parameter. Okay, so we figured it out. Center you rotate on isn't the center of the pinhole. Chris, I believe it was center of the... I didn't double check it, but I think it was center of my axis of rotation. So I think this is... I see what you're saying here, Chris. Let me... let's do a quick inspect. Let's see if I can get down to that. Let me turn some things off here. Let's turn this sketch off, and we'll just measure from that point to this point. You're right. It wasn't. Okay. Maybe I should go back and do a mirror, try and be clever and do a mirror thing across a plane that's 22 millimeters across. Yeah, I think that's probably what we'll do. So how best to do that? Why don't we, what sketches can we pre-use? I have a line here. Yeah, so we'll do a plane at angle. We'll go back to this plane, which seems a little cumbersome, but I think you're right, Chris, will be safer. So we'll offset this 22 millimeters, and then we will mirror this whole component across this plane. And because that plane was 22 because this plane was 22 millimeters from the center line of this hole, this one is also now 22 millimeters across the center line of this hole, and so this should really be 44 millimeters. But let's double check that. Come to our inspect tool, and we'll grab that point right down there, and we'll turn that sketch off, we'll turn that plane off, and we'll grab that point, and 44 millimeters. Okay. Whew, thank you, Chris. I appreciate you. Let us come back into one of our... I guess we can't do this in the hook holder directly because I don't want to mirror this operation. So we'll just do this in the root of our timeline. It's fine. It's not a terribly complicated part. We'll come back in. We'll project our horizontal line back in. And we'll get our... Oh, I was going to do this on a mid-plane, wasn't I? Because I want to extrude symmetrically. So let's do that. So let's create a mid-plane between this face and that face. And put a sketch on that is what I wanted to do. We'll project... Now, I suppose... Because, of course, we're not modeling off of the actual model of the physical snap pins that we're going to be using. I think that dimensionally they are the same. Like the center, where this truss center line falls in this hook is the same as the one we're modeling off of. But it occurs to me if I'm wrong, and they are different. We can account for that by adjusting this user parameter, right? The key thing is that the parameter that determines the center line distance between our shaft and our truss member is parameterized, and if it ends up representing a slightly different quantity than what it's named after, we'll just rename it, and that'll be fine. Okay, so there is once again our bearing hole, our bearing hole. So now we have to think about design. Why don't we just bring this out? Don't want to get too close to those pins, but I think that'll be okay. And we'll do a nice little chamfer down here in a second. We'll extrude this out symmetrically, total of 7 millimeters, and we'll join everything together. And there is our bearing support. You know what I really should do? I should make these pin clips the same size as this bearing support. Let's go back and do that. We'll just say, instead of dimensioning that to 3, we'll just say that the whole darn thing is 7 millimeters. There we go. So now it all lines up nice and tidy. Now it looks like my join didn't join everything, but that's okay. Let's see. We'll just do a separate join operation. We're going to join this with that and join. All right. Some weird artifacting going on here. Are these at least all one body now? No. Why is that? Let's see. We did this in this extrude. I have everything visible. Is it because I'm doing it inside this operation? Here, let's bring ourselves back to, let's delete that join. We'll bring ourselves back to this point in the timeline. I'll turn on that body. Let's go back to this point in the timeline. We'll delete that. Bring our sketch back. And now in the root of the timeline, I will say extrude, symmetric, 7 millimeters. Ah, interesting. 7 millimeters. It wants to join. You know what? Let's do, maybe this is cleaner. We'll do this as a new body, and then we will join our other two pieces to it. Does that work better? It does not. Huh. Okay. Is it because they're mirrored? Like, is the mirror relationship screwing us up here? Now neither of them will join. That's weird. I mean, ultimately it's fine because we are going to 3D print these and they're going to export as one STL. It's just a little bit weird. I mean, that'll chamfer fine, or fillet fine rather. Well, this side? Yeah, it's fine. Okay, so it's doing the things that I care about. It's just kind of being weird about it. But we'll just bulk up that fillet there. Maybe we'll do another fillet on top here, just to give ourselves a little extra support. Oh, I've crashed something. No, Fusion, no. Well, that's as good a time as any to me. Oh, I never did say. Tonight's beer of choice is a Two Brothers amplifier, a glare as always. Two Brothers amplifier. Hop volume 11. Citrus level 11 from Two Brothers here in the Midwest. Very tasty. As always, if you're drinking something interesting, I'm always curious to know. Even if it's just water, no pressure. Drinking is not everybody's thing for any number of reasons, and there's no wrong answer there. I was hoping that taking that little pregnant pause would uncrash Fusion, but I would have been wrong. Let's just, yeah, nice little 1 millimeter fillet there. It's not the most printable part. Yeah, so one of our challenges is going to be this center hole is going to print best if it prints in a flat orientation, but these pins are going to print best vertically, and I think that's what we have to prioritize. Excuse me. In fact, let me get rid of that fillet and let's make this somewhat more printable. let's do a tangent plane down here and a sketch on that, and project one whole body in there. And then we will just extrude, we will just extrude this up to this object and join it all together. Yeah, so that's going to be our flat printing service there. Ooh, Chris is having what? A Riverlands ice cream carton Neapolitan Imperial Stout. A Riverlands ice cream carton Neapolitan Imperial. Is it 3 colors of beer in one can, Chris? I mean, that sounds incredible, whatever it is. But I need to know more. Maybe I'll chamfer these? Can I chamfer a curved edge? Yeah, let's do that, just to give ourselves a little bit of class in here. Oops. Can't create that deep of a chamfer. Maybe something like that. Maybe this is our part. Oh, Epoch Cam connected via Wi-Fi. Thanks, Epoch Cam. That's the I don't know if you saw that pop, but that's the software that I'm using to do the this cam, which is just a Wi-Fi camera from my phone, working pretty well. All right, well that I think is our shaft support for now. I don't think it needs to be more complicated. Actually, let's say what. Let's bring that pin back in and see. Yeah, so I just wanted to eyeball, like, is the shaft actually going to clear this support? And it looks like it will, so I think we'll be okay. So let's save this out and get it printing. Save that. We'll put this in winch files, make a new folder for the date. I've been trying to be a little bit better about these longer running projects of like separating the drafts by day that I make them, just to have some sense of timeline. We'll call this winch shaft bearing support. And let's open up Prusa Slicer. Chris says, ice cream carton is a new 13% Neapolitan Imperial Stout brewed with cacao nibs, vanilla, and strawberry with no lactose. It's like the perfect scoop containing all 3 flavors at once. Holy beans. Chris, I'll be totally honest, I can't like mouth picture that, but all those words are really good. Yeah, like oh no! No! That's not what we want at all. I'll tell you what, let's export the whole. If I export this whole component, is it gonna bring that hook? It is. Let's see. Yeah, the fact that this won't join here is kind of. Yeah, 2 body. You called it, Chris. 2 bodies, so it didn't save out as 1. I could save this whole component as 1, but then it would bring this hook with us, which I don't really want. Updates for Prusa Slicer are available. Remind me tomorrow. Let's see here. I mean, I could delete the... Oh, man, that's tricky. I guess I don't understand. Let's see. What if I try to join... Oh, hang on. There we go. So we created a joined version, but by doing save tools, it confused it about what it was actually keeping. I probably clicked a save tools in one of those joins that I didn't mean to. Okay, so there we go. So we'll just include that. Actually, maybe we'll put, now that this is like doing this thing properly, maybe we'll put these fillets back in just for vanity's sake. And maybe we'll do a couple just here, just to be classy about it. There we go. That's nice. All right, let's save that out as an STL. All right, shaft bearing support. Yes. All right, and now we can just do a reload from disk, and now the proper model is there. And we'll spin this around. And let's do this at 20 let's do the default 20 millimeter to a 0.2 millimeter layers speed. That's going to be a 52-minute print. What time is it? 7:50, so down about 8:40 my time. That's pretty reasonable. And like this won't be the optimal orientation to print this circle in, but this circle for the bearings will be a lot easier to file out than these pinholes. So I think this is the way we're going to go. Well, let's get this thing fired. If it's really going to take 52 minutes, let's get this thing fired up and move on to other things. We'll say this is the print on May 8th. PLA. Hopefully I have PLA loaded in the printer. I suspect I do. I do. Let's get that preheating for PLA, and we'll steal the flash drive from the Riverlands. Chris, I like I say, I don't know like what exactly flavor profile that is. All 3 scoops of ice cream in a single bite. It just sounds really good. All right, let's get our. There. Helps if you actually plug the flash drive in properly. Winch, winch, winch. Physical designs as printed. We'll pull our G code. I guess I could show you the file system on this Windows machine. It's terribly exciting, but I suppose it's more interesting than looking at sort of the side of my head potentially. Oof, this poor flash drive needs a clean out. All right, so take the flash drive out. We will. I wonder. With this new camera setup. I wonder if I could actually like bring y'all up to the 3D printer a little bit better. Ooh, that's kind of fun. I mean, you'll be outside the Dexter shield, as it were, but let's see if that's a thing. Yeah, there we are. I mean, oh, something has frozen. Some camera is frozen. Oh no, my face camera has frozen. Which one? This one still works. Hello, but something's reset. Oof. Oh no, we're back to this again. So I think I've tracked down a little bit of what this problem is that continues to happen with this webcam, right? Where this is not the first time we've seen something freeze. I believe it's to do with static, because I noticed that one of my 3 monitors disconnects when I get a little static shock. So I suspect what's happening is like it's shocking something in the USB, and of course OBS really likes to be connected to, which is the streaming software that I use, really likes to be connected to all of its sources when you start the program up. And if it's not, and you turn them on partway through, sometimes it's happy and sometimes it isn't. So I suspect that like static is just causing a momentary disconnect of the webcam, and then it's just not coming back. So I'm not entirely sure what I'm going to do to solve that this evening. You can just look at my very still 3D printer here. What happened with the one side camera that was washed out? Oh, that the like one that was on the microstage for a while, Chris. That one I've replaced with this one essentially. I still have it around here. It's on a shelf, but it was so. I know you like you said the image quality was so poor that I figured it would be worth experimenting with the Epoch Cam solution just to give it a slightly better view. I'll get that started up now. Let it do its thing. Actually, this might be, I mean, you won't be able to see me, but I know that's not what we're actually, tuning in for. Let's see, did this come back? No. Well, here, while we're watching this lovely 3D printer do its auto-homing, which I do find very satisfying, why don't we see if we can get this camera to come back? Tiny frame, no. Let's see here. Base shot computer. The side cam view is washed out. Yeah, so Chris, that's what happens when I enable and disable that camera source. So like we're talking about this guy. Yeah, so like this, the Logitech drivers are garbage. And so when you like power cycle OBS or add or remove a camera or whatever, it resets all of your various camera settings. So here, I know what they are pretty much by heart by this point, so I will just redo them very quickly. I'll turn down auto exposure. Turn down the gain. There we go. That's not as miserable. But I wonder if this is still, yeah, there's just got a little tiny bit of the back of my head there on that camera. I think the thing to do, I hope the thing to do is going to be just to disable and re-enable it. Disactivate, reactivate. Hey, there we go. But again, of course, it's me, but in like a light, tasteful blue. Because again, the settings are, we're really just like getting into how the sausage is being made. But I guess all of this stream is really about making certain types of sausage. You're all nerds. I like you all, but we're all nerds here together. So I don't feel too bad about being like, I'm just gonna fix the thing. I'm not gonna like pretend it's not fixed. What does Chris says? To use Logic Capture? No. So I have tried using Logic Capture to like try and make the settings more durable, but I have not had any real success in it being any better than just, what was I saying? Any better than just, like, OBS seems to reset the Logicam settings every time I, like, power cycled them. Well, this is printing now, so that's kind of fun. This is kind of fun. If we ever were to, like, do something where we really needed to talk about what's going on with the printer, I'm a little trouble autofocusing because I have this visqueen screen here around it. It's not visqueen, it's 6mm window sheeting. Like you put on your windows here in the Midwest for the winter. And actually, it was exactly what we put on our windows this winter. We had a bunch of it left over, and so just put it around the printer. That's kind of fun. But that'll take us another 45 minutes or so to get through. So now I have the excuse of, while we're waiting, telling you about this other DMX project I've been working on this week, this sign. It won't take, I promise, I don't think Dave's with us tonight, but I promise this won't be a 45-minute story, but I do genuinely think that there are, if you're working with DMX on Arduino platform specifically, this may be of interest to you. Cookie says, let's see. He says, use Logic Capture creates a new source. I'm wondering if it would buffer the crash. Yeah, it doesn't seem to do any better for me than not using it. Something is loose in my mount here. Let's see if I can get this to stay. There we go. I mean, it'd be worth trying. Clearly, what I need to do is do some better earthing of myself, probably, or stop wearing synthetic shirts. Sorry for the sound there. Stop wearing synthetic shirts on stream because it's synthetic over cotton, and that's what I think what's causing a lot of the static. You can also, you want for a little inception? If I tilt this up too far, we just start to get like OBSception there. Yeah, we'll have a good old time. Yeah, Chris, yeah, 3 hours later, the story finishes. We'll see. Well, it's not so much a story as, like, I want to, like, the way this code came together is different from the way that Demilight code works, and I thought that might be of interest. Or of use, or at least of tolerance until we get back to the 3D printing. Here, stand by, let me wet my whistle before I dive. Okay. So, briefly the hardware. Sign from our friends at DC Digital, an Arduino Uno, which will be in a nice enclosure, a RS485 to TTL level converter. That's this guy down here. Little red board. Oh no, that's the little blue board. That's our basically our DMX converter to a level that the Arduino can tolerate. And then I have an RS232 from TTL converter that's taking the signals out from the Arduino and sending them to the sign because the sign natively speaks serial commands over RS232, right, which is another physical level spec that's often used to transmit serial-like data, right? So 2 converter boards, but ultimately it's it's my shirt. It's also our DMX coming in here, being converted to something the Arduino can listen to and sending commands out over RS232 to the sign, right? That's literally all the hardware is. It's nothing fancy at all. Just a couple of level converters. Protocol. Would you say protocol converters? Hardware spec converters? Line converters? Anyway, the interesting thing, I think, is what's happening in the code. So let's minimize Fusion for a second here. Well, if the computer starts to chug a lug, we'll have to come back. I'm going to close Prusa slicers to save a little bit here. So just to give you a little bit of a sense of why I think this is interesting, right? So here's some Arduino code, and we're not going to like walk through this step by step, but there's some interesting parts. We're defining like some various parameters, like what the start address of the DMX device is, how many DMX channels it takes, what the input pin is and the output pin is. Like this, all of this is not terribly interesting, but let me show you. We'll do some setup, right? We need to define some inputs and outputs. We do a fair amount of setup with our interrupt registers, and that's going to come back in a second. But once we've enabled everything, we set our start address, we said we're going to do this function on receive, complete, and enable. Here's our loop function. It's literally nothing, right? In our classic Arduino programming paradigm, we have our setup function, which runs once, and our loop function that runs over and over again. And our loop function is literally a no-op. right? Nothing is being pulled or called. All of the behavior with inside of this program is interrupts driven. And so there's nothing for us to do in this loop here. So what do we mean by interrupt driven? Well, I did I can't believe it's coming back. I did a whole video on interrupts in the Arduino ecosystem. I think it was like 3 videos. I think that's Electronics Bash 16 through 18, if memory serves, from sometime last fall, I think. And a whole nother one about DMX and RS-485, which gets some traction on YouTube every now and then, which is kind of fun. Check those out for more details on interrupt-driven programming. But the gist of it, and how the JDMX library, right, the DMX library that I'm using, which is adapted from the, it's forked from the Conceptinetics library, and a lot of the heavy lifting was done there. The way that it handles data processing makes use of a couple of the built-in interrupts that the ATmega328 handles, specifically this one and this one. So this is going to specify the interrupt service routine, the ISR, that should fire when our USART TX vector is triggered. And point of fact, this is saying write this code into a portion of memory, and I will point the interrupt vector that's triggered when we fulfill some requirements at this bit of code. And those requirements in this case are, there's an interrupt that will fire whenever the ATmega has finished outputting a byte of data. The ATmega328 has a single byte register, 8 bits, that you can fill with data either for outgoing serial or for incoming serial. It's the same byte. You fill that register with 8 bits of data, you enable transmission, and once all those 8 bytes have flowed out of the serial part, it will fire an interrupt for you. The idea being that you probably want to put another byte into that register so it comes out of the serial port next. And when it's done, it will fire an interrupt, and you'll put another one out, and so on and so forth, right? Similarly, there is an interrupt that will fire, and we'll look at these more specifically in a moment here. There's an interrupt that fires when you have received a byte of serial data. So, your serial hardware that's built into the ATmega is is receiving data 1 bit at a time. When you've filled up that register, when you have 8 bits, an interrupt fires off, because probably what you want to do is take that byte and respond to it, do something with it, or maybe just store it somewhere. And then that byte's going to be probably overwritten by the next byte that comes in, but it's fine because we've already done something with that data, right? So we have these 2 built-in interrupt service routines for what's happening once we've finished transmitting a byte, when we've received a byte. The receive of a byte ISR here is pretty much the same as in sort of like all the base examples of the JDMX library, right? So. And this, I was like 80% of this is from the Conceptinetics library. Like, I really want to be clear, like, I've done a lot of work on this library, but a ton, I'm standing on the shoulders of Conceptinetics giants. So, if you, like, all praise and credit to them, and thank you for licensing it under the GNU Less Republic license so that I could continue to work on it and release some improvements and changes myself. Very kind. So in our receive interrupt state is relatively straightforward. It has to sort of track a few different states of the DMX flow that we could be in, right? Are we receiving our break between frames? Maybe it's our very first, if we're receiving our break between frames, we probably want to sort of think to ourselves, okay, now we'll start counting over from, address 1, address 2, address 3. But if it's not, then I probably just want to, like, record that data into something. I'll call this process incoming function. And that's going to take care of doing a lot of things for us, including like recording the slot, the newest incoming byte, going to be recorded into one of the slots of a 512 byte array, so we can keep track of all of the various DMX values that are coming in. Maybe it's the start address, maybe it's just data, right? So the gist of it is that when we see a byte of data come in, we think to ourselves, video of static thingy. Static thingy me? Huh. When we see a byte of data come in on the DMX line, we cause the ATmega to say, okay, I've seen this byte, let me figure out if I'm seeing like a break or a start byte or some data, and regardless, store that byte somewhere away, and so when the user's like, hey, what's the value at DMX address 47, we just pull it from that array, right? That's all that we're sort of doing in this library. But getting to the point, a mere 70 hours later, the clever thing about this code, and that I'm really delighted to have gotten working is how we handle this and transmitting serial commands. So this sign, well, that's a wall. This sign accepts commands that are serial over RS-232 at 9600 baud. DMX is ultimately much like a serial protocol at 250 kilobaud, right? And like I mentioned earlier, one of the keys is they are sharing a lot of their internal hardware. They're sharing that same send and receive byte. They're sharing the registers that set the speed of the serial port. Because most of the time, right, if you've got a serial port, like when you're using the serial monitor in your Arduino IDE or what have you, right, you're probably going to be like sending commands at 115 kilobaud and then receiving information back at 115 kilobaud, right? You're most of the time you're communicating with a single device at a single speed. But I'm communicating with two devices at two different speeds. So here's how that works. When we reach the end of a frame of DMX data, remember each byte of this DMX data is just calling this process incoming function where we go and actually figure out what to do with this byte of data that we've just received. Right, so if we go to scrolling all around, let's go to our receive here, and I'll just use VS Code's very handy go-to definition function to find our process incoming function here. So if we've received all of our data that we plan on receiving, we'll call this event on frame received function. Which is going to do a few other things, but mostly it's going to transition us to transmit mode. We'll call it this set ISR mode function, and when we transition to transmit mode, one of the things we do, so we clear out our DMX data register, we fill our DMX data register with the first byte of data we want to transmit, and then we actually change our clock speed by changing two of the registers that control our serial protocol clock speed. Right? When we're in receive, we want to be receiving at what turns out to be 250 kilobaud, right? And this is the math that goes through and sort of calculates that for us on the fly. But this is just a static setup. And similarly, when we want to switch to 9600 baud UART transmission, we actually reset our data rate down to be much, much slower, and then enable transmission. Then we do some transmitting, and in our transmit ISR, we go through the 7 bytes of data that we need to transmit for each of the messages to the sign. And then when we're done, we call this set ISR mode receive. Again, when we go back to receive, we speed our clock back up, and we're ready to receive DMX again. So basically, every time we receive a frame of DMX, we slow our clock down, we transmit the 8 bytes that we need, then we clear everything out, speed our clock back up, and we're ready to receive DMX again. That ultimately ends up, I think I still have a capture here. Yeah, so this is a view from my logic analyzer from just a little bit ago, where I was doing a little bit of troubleshooting. So on our receive line here, receive 0, this is our DMX data. So we can see our interframe spacing, we have our break, we have our mark after break, and I go into a little bit more detail on how the DMX protocol works, that DMX and RS-485 Tronics bash from ages ago, but essentially, right, it's just a series of up to 512 bytes of data, and byte 0 is your start code, should be all zeros, and then byte 1 is information for address 1, byte 2 is information for address 2, and so on. And so here's our channel data. In this case, I guess I was sending 26, 255, 10, and then since it's a 12 address controller, it only sends 12 addresses worth of data, and then it stops. But shortly after that concludes, right, we do some processing. We say, okay, well, I'm done receiving all the data that I care about. Somewhere in here, our clock speed slows down, and now we send our series of much slower bytes, right? So this is what, 13 bytes of DMX data plus a break fits in this much space, we can tell. Let's measure it, put a cursor here, 734 to 735. So about a little under a millisecond for this much DMX data. And then we slow our clock down and we take another like 1.1 milliseconds just to send the first byte of our next command, right? And this is the point, we're just sending the character T. which says I'm going to start sending a command to you. And then we said TS00122. In that case, this means send a command to a static number with no colon, and that number is 0122, right? So that's the message that goes out. And once that's done, you can see actually here, so if we look here, we have our short little pulses are our DMX, our much longer sequences are our very slow serial. Once that's done, we actually see shortly later, we get another set of DMX data with no serial transmission. Because this sign has a maximum data throughput that is slightly slower than DMX max speed, what's happening here is we get one DMX packet, we send it out. We actually can't send another packet of information when this one comes out. That would be too fast for the sign to handle. So we skip this one and go on to the next. The timeout happens probably like right here. Like it's just barely too slow to keep up with full speed DMX. From my testing, it might, but it's outside of spec. So then we just catch up with the next DMX frame. So our refresh rate ends up being about 22 hertz as opposed to 44 hertz, which is plenty fine for this application. And then it just continues sending along and along and along. And then everything else is sort of like an addendum to that. Things like, the effect mode where it just scrolls through things itself, right? If the first channel is below 0 and it goes through this effect, that's just saying, okay, well, if channel 1's address is less than 120, or channel 1's value is less than 127, then rather than base the transmitted value on your, state of another DMX channel, we'll base it on something based on the current time, based, on program running time. And similarly, that's like, okay, well, if channel 3 is at a certain level, we'll flash. If it's too high, we'll blank the display, and so on. And if we're in raw mode, the state of that slider just changes the value. So there's that. So all of this is stuff that you can do. The only really clever thing that has some gotchas, as it turned out, was this like interleaving of the two serial states. Of receiving quickly and sending slowly. Things like this interrupt here, right? The interrupt that fires off when you have sent one full byte of data, and presumably you'd like to do something so you can send the next byte of data, right? It's really quite simple, right? We fire off this interrupt, and if we're in our send data state, I say, okay, well, we'll start down here. We'll clear out our status register, and then we'll say our data register, where that byte that's being sent should be held, should be a member of this array, this display number array. We'll take it from the current slot, and then we'll increment that slot. So we'll send slot 0, then slot 1, then slot 2, right? And that's mostly what you would do with this transmit interrupt. Is like, oh, I've run out of data to send. Where do you want the next byte to come from? Probably the next member of an array. Really simple. And then if that index into that array is greater than or equal to 7, then, well, we only ever want to send 7 bytes, so we'll switch back to receive mode. The gotcha here is this interrupt fires off not when that 8th bit of the byte is done being transmitted, but actually as soon as it is pushed out to be sent. And by that I mean, and you can see the artifacting of this, though I've pushed it out to a place that it doesn't matter to the sign. But what's happening here, so here's our serial transmission going out at its very slow clock speed. And then we see a little bit of goofiness here that goes, right? We've got our nice slow 9600 baud, and then we get this little bit of what I would technically call that has a pulse width of 4 microseconds. And that pulse of 4 microseconds is a 250 kilobaud pulse. This is what's happening so our interrupt that's telling us to reload more data is happening here. Right, as soon as it's happening here. As soon as the last bit of this byte is put onto the data register to be transmitted. So if we say, okay, as soon as that interrupt is triggered, I want to change clock speed, then this last bit gets garbled. It becomes shortened to 4 microseconds, to a very, very short time. So what I actually had to do is kludge in, like if we're going to receive mode, we actually set everything up and then delay a couple hundred microseconds so that we push this change in clock speed out until this byte is done. We can't change clock speeds right away, or we cut off our last bit. We have to do it sort of after the fact. And why we get one more byte of data here, I'm not entirely sure. But it doesn't seem to matter. So in any case, an interesting project all around, and full of those weird little gotchas, like when it says like, this interrupt fires when the data transmission is complete. Does that mean when the bit is done sending? No, it turns out it's when that bit has started. The final bit has started to be output, but not when it's done. Fascinating. At least I think so. And regardless, I had a great time. So I'm doing an acceptance demo tomorrow morning. Hopefully that goes well. If not, we'll continue to tweak it. But also like a fun way to like learn and think through a little bit more what it means to do a fully interrupt-driven program on a system like this, which you don't often get to do. So that's fun. Should we check on our printer? Let's see here. We're at 41%. We're 22 minutes in. Ooh, and it's looking nice. Here, now that I know that I have the ability to like bring the camera up and show this off, it's like, ooh, that's a power. Here, let's bring that there. Printing away. Seems to be going all right. All right, well, we'll check back in on that in a little bit. Let's get another part designed. Let's see. I think we should... So, like, the next large part that we need to design is the holder for the stepper motor itself. But I think where we're going to start is maybe by modifying to remember if it was Broke Both or Chris. I think Cookie, it must have been your point about coupling the winch to the shaft itself. Let's work that out. Because then at least we could test this setup by hand. I guess we still have to figure out how this attaches to the truss at some point. That'll be another modification. But let's open that part back up and do some modifications to it. So let's see, mid-shaft support, we'll leave that open for now. We'll close the pin clamp. And here's our winch. Ah, yeah, that's right. Last time we worked on it, we brought the... Oh, did we do some of this already? Oh, we started at least. Look at this. We put a bearing in here, and we put a shaft in there. Oh, we did think about that. Well, we thought about coupling on this side, right? That we were gonna put make this a D-shaped shaft and put the stepper motor right next to it. Still haven't figured out the mounting of this stepper motor. But Chris, I'm going to elide your question about what show has skee ball. I don't know how much our client cares if it's public or not. Probably not at all. But I think I'd best not say until that thing is on its feet. But why don't we think about instead how we're going to couple this to a shaft? I think what I'm going to do is actually draw on some information from the Kabuki drop project, because we ended up doing a set screw there. Let's see, where was that Kabuki drop project? Was it in the Moving Light PCB folder? Let's find out. Truss warmer, Kabuki, here we go. Kabuki demo, Kabuki bearing, clip clamp, Thomas coupler, Kabuki drop. Wow, we had a good old time. Clip clamp, curved truss. I'm looking for my, can I just search? I'm looking for that hook. I don't remember if it was its own separate part or did we do it as a component. Oh, here we go. Kabuki hook is what I was looking for. Mostly because the dimensioning we had here. Yeah, Chris, listen, Chris, over a beer sometime we should talk all about it. Maybe over a beer sometime here we should talk all about it, but not quite. Let's pull the dimensioning off of this. Because the dimensioning of like this hole and its relationship to the inside worked okay. So we might as well use that as a place to start. So let's see, how deep was this hole? It was about 4 millimeters in, I guess a curved distance here, but about 4 millimeters. And that makes sense because we were using a 3 millimeter deep, a 3 millimeter tall threaded insert. And what is our spacing of our overall hole here? 3.75, okay. So, what I think I want is, let's go into our barrel module here. And so this is the point where our snap hooks sort of clip on to keep this thing centered in its bearing. So we're gonna need some more purchase to actually attach the shaft to. So let's give ourselves like another, I don't know, 3 millimeters of space from that clip point before the shaft actually starts. And let us put a sketch here, and we'll come up with how deep we want our D shape to be. Now, our grub screws are going to be M3 grub screws. They're not going to be that big to begin with. It's only so big that this D can be before it really is not particularly helpful to us. So let's make using our friendly mirror tool again, we'll make a symmetrical shape here. And we'll say that just like to represent our grub screw would be 3 millimeters. Yeah, so that's our shape. So let's say outside of that, we want, we want between that point and that point a distance of, yeah, another millimeter seems about right. So that would be, okay, except I need to, this is the wrong circle to be putting this on. We will do a circle. So this circle will represent the clearance hole of our shaft itself. And that's going to be 3/16 of an inch plus 0.05 in all dimensions. There we go. Okay, so this is what's going to become a D-shaped hole. And similarly, we'll do a shaft there, and we will say that the total length of this line probably just wants to be 4 millimeters for an M3 screw. And then we will extrude that out for, let's say, 12 millimeters, half an inch or so. That's pretty deep, but I think we won't be sad about it. And, so one thing that's occurring to me is, like, we're probably going to print this shape pretty strong. All of the torque of that winch is going to be going through these pinch points here, if you will, and then transmitted through this D shape, which would be kind of exciting. But we'll see how that goes. Now, I guess one thing we should determine is, do we have enough room here to put like a 5 millimeter deep hole? Let's make that line coincident with that. And let's see how long it is. 2 millimeters. No, we definitely don't. So let's do a little slot. We'll do a center point slot that goes horizontally and is as tall as our shaft. Oops, I've made it a construction line slot. And we'll do this just to give ourselves a little bit of extra plastic to put our grub screw into. And we'll do it as a slot so it's sort of symmetrical. And we're going to want, let's see here. Maybe I can reuse this line from earlier since I'm not using it anymore. Yeah, there we go. Drag that out here, and we'll say the distance from there to our D-shaped hole wants to be, so we're putting like a 5 millimeter deep hole in it, so let's make this 6.5 millimeters. And we'll make this tangent to our shape here. There we go. Now, when we extrude that out, now we'll have enough room on this side to actually put our grub screw into. And we can like clean up this transition some, right? We can chamfer this off or something. I wonder how well that'll go. Let's see if I were to just like start filleting out this circle. Actually better than I thought. That went pretty well. A little bit of a goofy shape, but I don't hate that. And this usually prints with, so this will be our new bottom surface for printing orientation. But I think that will be okay still. It's not any smaller than what it used to be, so that'll be fine. Let's see, so our kabuki hook hole here, let's just see here. The outer hole was 3.75, the inner one was 3.2, and the depth we said was like 4.2. So what we'll do is create a tangent plane on this face and a new sketch there, and we'll bring in our interior hole. We'll bring this across, And I wonder if we want to do 2 grub screws. Is there any value in that? 3.75. Oops. Not 43.75, 3.75. There we go. Maybe not. I mean, we can always experiment with that at some point. So it's going to be a fairly major... You know, we could do them symmetrically. That might be kind of nice. If we're going to do them symmetrically, is there a smarter way? There might be. Maybe if we were to do like a mirror feature command. But let's come to that in a second here. Let's try out this design first. So I'll put that on center. We will extrude this by, what did we say, 4.2? Oops, by minus 4.2. And we'll make our inner circle here on this same sketch, because that's just going to be punched let me punch it all the way through this shape. There we go. Extrude all the way through. Cuts through there. And we'll do a tangent plane over here. Yeah, this is... Maybe there's a faster way to do this, like mirrored cuts from either side, but I can just project the cut from the opposite side and then extrude it back in. We'll do that form, and it wants to go in minus 4.2. There we go. So there's our two holes on either side for a couple of grub screws to go in and grab. Now, if that's going to be the case, would I want to like file down both sides of this shaft? Probably, right? I'm worried about how much torque this is all going to be under. Maybe we go back to that earlier sketch and rethink the shape of this hole. Because if this was 3 millimeters, yeah, this I think is the way to go. And we'll just mirror that across. So I'm going to do some semi-precision filing, which, as you all know, is my forte. And I'm sure would go fine. And what could possibly go wrong? But thankfully, I really just have to file it down so it fits inside this slot, and everything else is sort of done for me. So that's going to be like we'll file down the end half inch of our shaft so it fits in there. We'll put a couple of grub screws on the side to lock it in place. And then that's going to transmit power out to the rest of our winch. And it's really starting to look like a thing. I'll be curious to see, so like in our current design, we have, especially if I turn it back, did I put a bearing here? Did I remove that bearing? Maybe I hit it. Yeah, there we go. So right there, so there's a bearing right here, right, very close to the point of power transmission. I'm curious, once we get these shaft supports printed, are we going to need a second one immediately after this point? Because this is going to be a huge point of, like, this is where all the torque from the servo motor and this mechanism gets transmitted to this metal shaft. Right, there's going to be a lot of torque on this point. This is kind of I fear this is going to be a weak point of our system. But there's not really any way to know that until we actually get the thing printed, I think. Yeah. Let's do a quick test slice of this and see how it looks. It seems like it's still printable, because as this thing gets taller and taller, I worry that it's going to become like infeasibly flimsy to actually get it printed. But let's see here. Yeah, save as binary, winch as barrel. Import barrel design, and this is actually 180 from how I have been printing it. So it's been printing like, come on, snap, there we go, like this. And that doesn't seem too absurd. The other thing I've been doing is using the painted on supports and doing like a support layer kind of casually around the outside rim here. So at the very least, as it gets to this sort of tall and unwieldy section, it will meet up with the supports that will have been growing around this print from the base, and at least provide a little bit more stability as it prints the threads up top. That's the theory anyway. So what happens if we do an adaptive quality slice? So one of the things that the adaptive slicing is really nice is it gives you some really low layer heights for like the threaded section, for example. Yeah, so here's an adaptive going down quite small. If we were to slice that in PLA with no other changes in settings for toughness, oh, that's only an hour and 18-minute print. That's actually not anywhere near as bad as I thought it was going to be. What if we jack up the infill to like 40%? We do, oh, we're on 3 perimeters. Let's do 5 perimeters and some additional solid top and bottom layers and slice now just to see like how this becomes. It's an hour 35. Well, that's pretty reasonable even still. I might go to even more perimeters. I mean, because like look at this is, you know, only 8 or 10 millimeters across, and this is that pinch point that I was worried about. Yeah, so that's almost solid already, I guess. But this is the point, like this in right where this is slicing in here is where that bearing goes. That's on the winch mount itself, and then there's this neck down for the clip, and there's one more here. There's a little tiny bit of infill left inside of it. So like adding more perimeters doesn't really help us much there. Yeah, so this is, I think, feasible as a print. It's just a little bit. Now, why didn't I? Oh, you know what I didn't do? I painted on supports, and then I didn't actually enable supports. So let's do that and see what that looks like. Support on build plate only, and slice that. Now we get our support layer in. Okay, this looks more familiar. That's 2 hours and 20 minutes of a print, which is still not bad as hobby prints go, right? And you can sort of see, I'm gonna step that back some. I went a little bit hog wild with the supports here. I don't want them coming into, oh, you know what? You know why it's going so far in is I don't want support on build plate, I want support enforcers only. Because I really don't want these supports touching the parts until they get to that sort of large upper area. And it seems like that's not what we have here. Here, let's go back and remove some of these support enforcers that I sort of casually lumped in here. Got a little too excited with my support enforcers. And now we should see if we go down through our print here. Yeah, so we're staying clear of our part until we get to this sort of like angular section, and then it starts to meet up with our part. We're sort of surrounding it in a quiet cocoon, and then we provide a little bit more support as we finish up the top section here and things get really top heavy. And this is still a 2 hour and 21 minute print. So that's not bad at all. I think that's something we could certainly do. And maybe, anything else we want to add to this? Maybe this will be my overnight print tonight, is this new barrel part. I guess we should think about how this winch mount connects to our truss. That would probably be good. I think I left room in these corners, this corner here and this corner here, to fit those pinholes in. And again, those are going to be in this orientation, left to right across the surface of the winch. So maybe, I think we're still going. Yeah, we've got another 10-15 minutes on the print before it comes out. So maybe we'll slap those in real quick. Now that we've gone through that process once, I feel a little bit more confident about being able to do it again here in some kind of hurry. And I guess it won't. Oh, but we're going to run into that same problem where it's not really going to be parametric because I've already have this design that it's based on. Well, let's see here. Why don't we see? So right now, distance from the center of, say, this hole. Let's see. Let's find a convenient place to take a measurement off of. Let's see here. Let's get rid of some things. Let's close the barrel out. We'll get rid of this extra bearing in here. We'll get rid of, let's say, everything else except the frame. Let's just look at the frame. And let's bring up our sketches, because I suspect some of these will be useful. Yeah, so from center line of our barrel to the top surface here is currently 23 millimeters. I'm sort of wondering, do we just set that distance at 30 millimeters that we were looking at earlier? For the sake of this design, at least, right? Like, that seemed to be workable. be 7 millimeters above this. So we'd have a 7 millimeter offset between our winch handle and our truss. That feels about right. And that leaves... Oh, except that puts that hook like right, like the center line of that truss is 7 millimeters above this, but it's really, well, I guess this could embed, this hole could be like that deep into the thing. It's kind of interesting. Let's play with that. Let's see how that goes. So we'll go back to our main timeline and let's bring in that hook we were using earlier. Moving light PCB, pin squeeze clamp. There we go. Okay, so this is just for eyeballing sake. We're not gonna get too fancy just yet. So it actually will center on this circle for us. We'll move that point so it's level with the top section here, and we'll move it up 7 millimeters because we know that our top surface here is, oh, camera problems again. Oh no, well, I'm still here. Let's see. So let's see. Thanks, Chris. Face shut table. Yeah, let's see. Last time just deactivating and reactivating it brought it right back. Hey, there we go. Again in blue. Just for my vanity's sake, I'm going to fix the color temperature one more time. But if it happens again, I just won't worry about it. Change the gain, change the contrast. There, that's good enough for tonight. I'm really only very tiny in most of these. Oh, and well, I guess this one I probably should fix because I'm just an absolute ghost, huh? Tabletop, camera, computer, camera, configure. At least let's turn the gain down. Choo, choo, choo. Turn our color temperature back up. And color temperature, and some contrast, and some gain. Interesting. We haven't had this problem for a while. I wonder what's different. I mean, the Epoch cam is plugged into one of the USB hubs. I wonder if that's doing anything. Whew. So this is just to like gauge the relative position of our hook in our shape. If we were going to have a 30 millimeter on center to center from truss member to barrel, and this seems untenable to me. I mean, we could do it, but like, look how snug the hook is not even clearing the top of the thing. So let's see how high we have to get it to clear the top of the thing. If we did 17 millimeters, so that would be with that's a 40 millimeter center to center spacing, I think. Let's see, and could we do the same thing up front? I think we could. So I want to have 2 sets of hooks on this. Yeah, okay. I can get behind this. So 40 millimeters on center. I dig that. So before we bring this pin in then, let's do some setup with our frame. Just so we get this exactly where we want it. So let's put a sketch on this top layer here, and let's project in what? Project in, let's say, these outlines, and let's bring in this other one too. We'll do a front and a back, and we'll mirror them as before. We'll do this bottom shape here as well. Okay, so now, this is sort of the pillar within which we must fit our shape. And I guess we should project in the fact that this pillar has a weird internal cutout as well. So that's kind of what we're working around here is the shape of basically of this section of the leg, which is not that deep. Is that going to be deep enough? 4 millimeters? Maybe not. But we're not going quite that deep. So really we're working within this shape, which is this shape. So I'm sort of muttering shapes to myself, but I think it will all ultimately, hopefully, come clear. So let's see. So there's center of that shape. And let's see. Oh no, because it wants to be center. Sorry, lost in thought there. So that actually wants to be center of this shape, and then we want a point that is the center of this, I think. Okay, so I think it wants to be centered just there, and then we'll offset it down. Okay, let's try this before I lose my mind just muttering sounds of shapes. We'll bring this into our root. I'll bring our squeeze clamp in. Yes, proceed. And we'll start with our point-to-point move to center things up on that point. And then we'll move this. Is that the right point? That's definitely not the right point. We'll move that 1, 2. And we'll move up by 17 millimeters, we said, I think. 17 millimeters. Does that put us where we want to be? No. I mean, ultimately, as long as this pin is entirely within this this leg. Oh, but it's got to be on a 44 millimeter center. Jeff, what have you done? All right, let's see here. Let's go back into our sketch. Let's pull our center line, and let's pull our 22 millimeters. Oof. So that's where because our hooks are going to be this away. So they have to be on 44 millimeter centers across the truss. Just there. So our maybe we just, you know what we're gonna do? We're gonna hang some additional legs off of this piece just to support these pins, and that will be just fine. So let's put this at 3 millimeters, and these want to run left, right, huh? All right, so make this collinear, and we will do another mirror command, my favorite command, across this line, and we'll mirror both of those, all 4 of those across this line, make ourselves a nice little leg to hang on to, and we will extrude those down by, what do we say, 13 millimeters? Sure. Maybe 15 millimeters, sure. Alrighty, now that wasn't even in the right component. Do I care tonight? I do not. Let us move our squeeze clamp into position. We will take our point-to-point move. We will take our center point, and we will map it to our... we're going to need another point on this sketch to do something with. Oh, it wasn't a component. Hey, how clever am I? All right, so on this new leg, we have a center point. Okay, good. So that's sketch 9 just here. We are going to point-to-point move our pin clamp, point-to-point move of the center point there to the center point there, and we'll slide this over to center it. goes there. And we will move it up by 17 millimeters, and it will be right there. Of course, our thing is not quite deep enough. Maybe we want to go a little higher. Maybe we want to go to 45 millimeters. It's higher than I'd like, but I think for the sake of this mechanism, it might have to be. Yeah, I think that's what it's got to be. So let's make this extrude a little bit deeper, and then let's hide this. We'll make a plane at angle. Yes, capture through the center point here, and we'll make it visible again. Oops, we'll make a plane at angle at a 90-degree angle. And then we will extrude this to our Wait, why didn't it capture my position? What the heck? I moved that so carefully. Well, dang. Alright, well, let's try that again. Let's move. Get this guy moved over, and it will go and check another 3D print, and we'll go somewhere else from there. So that moves over to here. Oops, no. That point-to-point move, center point there, moves over to center point here. We chooch it over 2 millimeters to be centered. Yes, okay. And then we move it up 45 millimeters. Sorry, 17 plus 5 is 22. 22 millimeters. Is that right? Yeah. And let's move it in 2 millimeters. All right, there we go. And we will capture that position this time. We'll hide our frame. We'll construct our plane at angle through the center of our pin. We'll bring our frame back, and we will extrude this to that center line, cut it down, be a weird looking thing, but that's all right. Do I have room in there to do this? Just looking at my physical model here, trying to thinking about it in relation to am I gonna block anything by putting that there? No, I should be okay. So what I'm actually gonna do is go back into my frame and kind of fill in this corner. Alrighty, so if I were to take some additional profiles and extrude them down, I'm not blocking anything. And that'll make it less heinous when we when we ultimately do that and cut a bunch of it away. In fact, why don't we extrude even a little bit more of this guy? There we go. All right, and now we come back to our pin. We do we do a cut, not a join. We do a cut. Cut, keep tools, okay. Now we lose that. And now, just like before, oops, not that plane, we do a sketch on this surface, and we extrude this down. 13 millimeters, I want to say. Oop, too deep. A little too deep again. That's fine. That's fine. Okay. So something like that. So really what I want is when this gets extruded, I want this to be a new body. And then I create a mid-plane to do a symmetrical thing between the two sides. Then we mirror this body across this plane, and then we join those, and we have, oh, why did this cut stop working? Oh, because I changed, because the body's no longer in the thing. Target body is this. No, target body is, no. Target body is this little guy, cut. And then we mirror across. Yeah, there we go. And then this, join, don't keep tools. And we avoid the same issue we had last time. And there we go. So now we have 2 pin clamps at least coming out of our winch support. And we have to, I think we'll do 2 more on the other side here. But, yeah. Oh gosh. For anyone who's still listening to me ramble on about extrudes and sketches, let's see. Oh, and we've lost the camera again. It's all going great tonight. Let's see. Deactivate, activate. There we go. Vanity be hosed. We're not going to try and fix that again. We're going to see how that print did. All right, here. Let's see. Yeah, here we go. There's our lovely little print. And, ooh, I should have maybe made that a little bit bigger. Maybe not. I think what we did for the Demilight is we actually did the cut and then like as a part and scaled it up by like 3% to give ourselves a little more clearance. I mean, that's very tight. That's not I can get it in and it's not going anywhere. That's actually not so bad. Maybe that's just printing roughness. And then that hooks on there. And there's our winch support. Hey, that's great. Look at that. Now, of course, the real proof will be this was printed assuming this was a 30 millimeter center to center distance. Let's go back to that part. This will be the proof of the pudding. Now that we decided it needs to be more, if we go to 45, does it work? We will go to our user parameter, and we will change the value to 45. Hit OK. Ah! Well, it kind of worked. Let's see. What broke here? Let's roll our timeline back until things start looking okay again. There's our circle. There's our ostensible join. Oh, you know, part of what it is this didn't turn into... I guess it is technically one body. Let's see. What was this tangent plane supposed to be? Missing cylindrical face. Is it this? So let's see here. So what we want is, let's see, let's make a sketch and take some measurements here. So did this really readjust itself? This distance from here to here? No. Sort of the opposite. 21 millimeters. Oh, but that's not the distance we care about. We care about the distance. Where is that circle defined here? 45. I can tell that's wrong. Because yeah, something is not right. Something is quite wrong. Or is it? Let's see. So if I inspect from there to... I wish I could inspect by circle center here. That would be awfully convenient, wouldn't it? Let's inspect from this line to... We don't really have a good line down here. What's this line? To this point? Oh, maybe it is. Maybe it really is 45 millimeters. So maybe I just need to clean up how this actually ended up, and we'll be in business. So I think the easiest way, we'll just create a sketch here. We will project this other body in. We'll make a rectangle between the two. And we will extrude from here down to this object. And we'll just make a nice solid block of a thing, and that will be just fine. And honestly, now that we're making that huge, we could probably make these chamfers bigger. Or maybe we couldn't. I don't know why it's limiting how much I can chamfer these. That's very strange. Oh! Hey, Kenneth. Yeah, you're here for the bad color temperature stream, for sure. Wow, that was like 5 minutes of just staring at the side of my ear while I talk about things you can't see, huh? Straight to voicemail. Hey, that's a feature. Yeah, you don't. I don't think it's after the time that I would normally voicemail out. Probably need to fix that, huh? All right. Well, but thank you for saying something, Kenneth. I appreciate it. But I think we're gonna wrap it up there. Between camera issues and brain issues and Fusion 360 going to maintenance mode in 4 minutes at 9 p.m. Central tonight, I think that's probably a good place to call it. So yeah, that's the return to form. Wow, I'm gonna talk and adjust my color temperature at the same time because I just can't look at myself in like a 4700K. It's gonna make me nuts. As I say, thank you very much for joining me again on this Saturday night with our slightly reschedule. I appreciate all of you. I hope you're all staying safe out there and washing your hands and getting hydrated and getting vaccinated when you certainly can. And yeah, thanks for flowing with the weird change up in schedule and sticking around as I regale you with these strange 7-segment projects that I am getting into these days, and hopefully getting more progress on the winch as prints keep going. So yeah, lovely to see you all. Chris, Cookie, Broke Both, Kenneth, thank you for popping in. And yeah, I will hopefully, let's see, I will probably be back on Sunday next week, Sunday night, as opposed to Saturday. We're back on the regular Sunday night schedule at 7 p.m. Central. If you have questions or thoughts in the meantime, Twitter's the best place, at JeffersGlass. Demilight Project is all on jeff.glass/Demilight. And yeah, you're all good people. Most of you. And I will see you next week. Have a good night, y'all.